Max Learning Fun. Hello everyone, welcome to Max Learning Fun. Today we are going to see chapter 1 number system. Max exercise 1.1 and 1.2 basics and with some sums, exercise sums. So class 10 real numbers. Yes. So today we are going to see the basic theorem. First we need to know that, which is so basic that fundamental theorem of arithmetic. What is this fundamental theorem of arithmetic? So, this is number 2. What are the products of 2? Yes, 2 can be written as 2 times 1 as product of 2 numbers. So, any other number? No. So next, let it be 3. 3 can be represented as 3 into 1. Next, 10. Let us go for composite number. What is composite number? Number which has 2 or more factors. So the numbers which have 2 or more factors is known as composite number. So for example, 10. So how can we write 10? 10 can be written as product of primes as 2 into 5. We should notice that 2 is a prime number and 5 is a prime number. Next, let's take 100. What is 100? 100 can be written as 10 square. We all know this basic. 10 the whole square is 100. We know that 10 is 2 into 5. So can we replace 10 with 2 into 5 the whole square? So by a into b the whole power n, 2 square into 5 square is 100. So here 2 is a prime number. 5 is also a prime number. So any number, every number can be written in form of primes, product of primes. Now for example, next. So any number that is natural number, capital N, can be represented as product of primes. Prime number means what? The numbers which have the number itself and one as its factors. So these are what? This is the fundamental theorem of arithmetic. Next, LCM into HCF. relation between LCM and HCF of given two number. So I am not going to take any alphabets and confuse you. We are going to see an example first with real numbers. So let us take 18 and 12. Now find HCF and LCM. So what is HCF? L division, you all know. So take 18 and 12. Now these two goes in two tables. Then 9s are 6 are. 9, 6 goes in 3 tables. 3s are, 2s are. Now these two tables won't go in a same table, multiplicative table. So HCF of 18, 12 is 6. 2 3s are 6. LCM means same. Till what? Till we get 1 we should do that. So 3, 2. So what is LCM? 3 2s are 36. So what does this theorem tells? See, here relationship between LCM and HCF is if we multiply LCM of 18, 12 with its HCF, you will get the product of two numbers 18, 12. See how it's coming. Ipo, what's LCM of 18, 12? 36. HCF 6. So LHS 6 6 are 36. 6 3s are 18, 19, 20, 21. 216. RHS. What is 18 into 12? That is also 216. So by 1 and 2 what we can tell? LCM of 18, 12 into HCF of 18, 12 equals product of 18, 12. So this is the relationship between two real numbers, natural numbers. So we are going to simplify and write it as C. If we represent this algebraically, how we can represent this? Let the numbers be A, B. A, B are prime numbers, natural numbers. So A, B are natural numbers. So LCM of A, B is AB. How means see A, B. A means B. Multiple. Next, HCF of A, B. The both numbers goes in only one table, 1. So relationship. What is the relationship we know? LCM of A, B into HCF of A, B equals A into B, product of two numbers. So LHS, what is LCM of A, B? AB. What is HCF 1? AB. So let this be first equation. RHS, product of two numbers A into B, AB. 2. So by 1 and 2 what we can infer? LCM of any two natural number into HCF of any two natural number equals product of two numbers. Understood? Yes. So we will see some examples regarding this, or we will see exercise 1.2's introduction also. So we are going to revisit some irrational numbers. So what is the basic definition of irrational numbers? See, irrational number has non-recurring, non-terminating what? Decimal expansion. Correct? True, right? So for example, we will see what is root 2. 1.4142 goes on. What is root 3? 1.732 goes on. What is pi? We know 22 by 7. Pi is an irrational number. How? 3.14159 2764569 goes on. So if you notice that, is the decimal expansion recurring? Does the numbers repeat? See, 41423, again 414 is coming? No. See here for root 3, 732, is 732 repeating? No. 141592, 764569. Are we getting any repetition, or is it terminating? The number mudida illa. So these numbers are considered as irrational numbers. Irrational numbers. So next, see, we are going to prove a irrational number and irrational number. So we are going to prove something that we know. Yes. We are going to see root 5. So basically they will be asking root 5, root 3 and root 2 as 5 marks, and sum of 2 as a rational number plus an irrational number. We will see those sums. So see. So we are going to prove root 5 is irrational. How we are going to prove this? See, so we are going to consider root 5 as irrational, and we are going to prove this as irrational. So this method of proving is known as contradiction proof. Contradictional proof. We are going to tell something that is false. Root 5 is rational. That is false. But by using that statement, we are going to give a counter statement using theorem, and we are going to prove that is irrational. So you will see that ஒரு விஷயம் வந்து போய் ஒரு விஷயம் வந்து உண்மை irrational root 5, ஆனா அதுக்கு ஆப்போசிட் என்னது rational. அது வந்து ஒரு rationalனு சொல்லிட்டு அதை என்ன பண்ண போறோம், irrationalனு ப்ரூவ் பண்ண போறோம். irrational வச்சு irrationalனா அதை எப்படி ப்ரூவ் பண்ணேவா இருக்க முடியும்? இல்ல. அத அப்போ ஒரு ஆப்போசிட் வச்சு தான் கவுண்டர் ஸ்டேட்மென்ட் கொடுத்து என்ன பண்ண முடியும், ப்ரூஃப் கொடுக்க முடியும். சோ என்ன பண்ண போறோம், we are going to take root 5 is rational. So we should not write root 5 is rational. Let root 5 be rational, because that is a false statement. So we should assume it. Let root 5 be rational. So that what? Root 5 equals a by b. Correct? For rational number, denominator should not be 0. And then a and b belongs to, or else a and b are integers. Integers ன்றத விட we can write co-prime. So that, see, root 5 equals a by b. Now we are going to square it on both sides. Squaring on both sides. So what? Root 5 the whole square equals a by b the whole square. That is 5 equals a square by b square. Correct, right? Now b square equals a square by 5. So what does this state? 5 divides a square. 5, if 5 divides a square, 5 divides a, 4 by 2. If 4 divides 2, that means what is, let's take 6 and 2. 6 square by 2. We can write 6 square as 6 into 6 by 2. 6 square is 36. So if 2 divides 36, then 2 divides 6, right? 3 times, right? So using that we are writing this. If 5 divides a square, 5 divides a. Divides a. So if p divides, p is a prime number, p divides a square, p divides a2. Next, so let this be the contradictory statement 1. Proof, counter statement 1, and let this be the assuming statement a. Let in this equation a equals 5c. We are proving for 5, we should take 5c. We are proving for 3, we should take it as 3c. We are proving for 2, you should take it as 2c. Let a equals 5c in which? In equation 1. So that equation 1 becomes, so substitute this, b square equals, in place of a we are substituting, so 5c the whole square by 5. Now see, b square equals 25c square by 5. So 5 ones are, 5 5s are. b square equals 5c square. So this b 5 will go there. So b square by 5 equals c square. So what does this mean? This means that 5 divides b square. So 5 divides b2. It's not b2, it's b also. This, compare this with theorem. If p divides a square, then p divides a2. Let this be counter statement 2. Now we told that a and b are co-prime. Co-prime means what? The number's highest common factor is 1 and only 1. The number's prime factor is what? Only 1. But after proving, after doing some methods, we found that 5 is a factor of a. Leave it, because HCF should be 1. If a has 5 means it doesn't bother b. But after further proof, we found that 5 divides b also. That means what? 5 is a factor of b square. Isn't it? So this means HCF of a and b is what? 5. It is not 1. So by as counter statement 1 and counter statement 2 contradicts fact A. A is the fact. It is contradicting the fact, right, that A root 5 is rational. Root 5 doesn't have a rational number as its factor. So, as this contradicts the fact A, root 5 is irrational. So, for upcoming 10th, they will start this chapter soon. This video will be useful. So thanks for watching. Subscribe to Max Learning Fun. If you have any doubt, kindly comment in the comment section. Thanks. Thank you. So yes. Bye.